great, then that's your phase shift. But wherever your graph starts, whatever equation you're looking at, in the place you're choosing that equation to begin. So that's the pi over 8. So to write the equation, we have a 2 for the amplitude. We looked at the sine portion of the graph. The b value is 4. And then you don't have to have the b in parentheses. It's easier just to keep the b out. Then inside, it's always x minus whatever your phase shift is. This doesn't have a d value because it's not shifting up or down. So we don't have a +5, a +2, a -3. There is no sinusoidal axis. It's just at y equals 0. So 2 sine 4, because 4 was b since the period was pi over 2. And then x minus pi over 8. Virginia.
Would you have to plug 4 in because it's just the x minus?
You don't have to. You will not be asked to write it like that. You could if you wanted to. So you could have 4x minus pi over 2. That would be the same exact thing. So I'd like you to see if you can write an equation for cosine. Libby said the only thing that changes is the phase shift. So when you're writing an equation for cosine, you should still have the 2 for the amplitude because it's still the stretch of the graph vertically. The 4 is still the horizontal stretch of the graph. The cosine just starts at the high point and ends at the high point. So wherever you pick your graph to start, for cosine, it needs to start up high. So another equation would be x minus pi over 4. That's one option. So you could come up with a different option. You could make a negative and start it at pi over 2. Like multiple answers, not just one, when you're writing equations. Questions?
So if I wanted to do like a sine or even like cosine, where it's like, let's say I started it at like negative pi over 8, so that would like, it would be going down and then up. Could I do that and just make the amplitude negative?
Yeah. So if you didn't want to have a phase shift, like you could start the cosine graph right here on the y-axis, and then it wouldn't have a phase shift. So we could come up with another equation for cosine, but it's a -2, and then it would just be cosine of 4x. But it's negative because it's starting down below. But then it wouldn't have a phase shift. So you could do that as well. Other questions? So the key thing is where you're starting your graph. Choose a place to start it. Go to where it finishes. But the sine graph has a hill and then a valley. Cosine graph starts high and high. That's an easy one to look at visually. So today we're going to take this wonderful equation information, try and interpret what a word problem is asking us to do. We're going to graph a word problem, and then we'll see if we can try and create the equation that goes along with it. So anything that has circular motion creates a sine or cosine graph. So we're going to look at a water wheel today. Your homework is a Ferris wheel problem and a clock problem. So going back to like what, first grade when you learn to read clocks. It's going to kind of get you to look at like 12 o'clock, the 3 o'clock, the 6 o'clock, those basic hours, half hours. So those are in your packets on page 21 and 23. I think I have a couple of, I might have left the extra assignment sheets down in the other room. I might have left a lot of stuff down in the other room. Oh, I get scared when I leave stuff in Herr Dibel's room. Must be down there. It's safe. I'll get an assignment sheet for you at some point, maybe tomorrow. But just things to note, like Friday, unfortunately, yes. You have a Friday, not on December 2nd, but on December 21st. Someone erased my one. So tomorrow we're going to finish up writing equations. Thanks, Brandon, for putting that one back in there. And then Wednesday and Thursday we're reviewing for your test on Friday. There we go. And again, I know it's crappy to have a test the day before break, but if you didn't have a test, I'd be teaching. So I can give it to you on Thursday, and then we'll teach on Friday. That's my Merry Christmas. You'll have like a little bit, because we're gonna start graphing cosecant and secant and tangent and cotangent. So like the chart you filled out for sine and cosine at the very beginning, you're gonna like graph secant and cosecant the way we graph sine and cosine by plotting like all those things. So we'll talk about that on Thursday. Oh, stupid thing. So if you look at the word problem, this is page 21, or no, 19. So find page 19 if you haven't already done so. This is the water wheel problem. So water wheel is like old-fashioned farmhouse. They have like a little stream going through. Actually, it has to be a little more than a stream, but maybe a little river going through. They've got a pond. The water wheel has a bucket on it. It picks up water. It spins around, creates electricity. You guys know what a water wheel is, right? It's like a windmill, but it picks up water instead. So this water wheel, pictured here, little diagram, says it rotates 6 revolutions per minute. So that's how fast it's spinning. So every minute it's spinning 6 times. So it makes 6 revolutions. I'm going to underline it. Probably important information for us to think about. Maybe. So you no longer have a stopwatch, but you have your cell phone, and you're like, hey, I have a time. See how long it takes to go around. So currently at point P, that's where our bucket is, and you take out your cell phone, you put your little timer on, and you hit start. And you notice 10 or 2 seconds later, the bucket is now at the top of the water wheel. So it's just like a Ferris wheel. You sit on the little chair for the Ferris wheel. So 2 seconds later, you're at the top. That's where the bucket is. You are to model the distance d of point P from the surface of the water in terms of the number of seconds t, based off of what your stopwatch is telling you. This is the water here. So the x-axis is the water. The wheel has to go in water to pick up water. If it was above it, it wouldn't get any water. So your goal is to write an equation, sine or cosine equation, to show wherever the bucket is, the distance from the bucket to the water. That's our end goal, based off of a given number of time, number of seconds. So we're going to try and sketch the graph. Even though it's a circle, we're going to try and pull it apart and make it into a sinusoid, which is a sine or cosine graph. And then we're going to get an equation. And then after that, we have the equation. Then we'll talk about predicting for 5.5 seconds. But that'll be the last thing we look at. So before we actually work through the bottom questions, if you can draw yourself a semi-straight XY axis. I just went up to 15. I went up to 15 and over to 15. So on Friday, we had the same kind of questions for you to think about so that when you have a graph, you kind of know what pieces of information you're trying to use to write the equation. So this is the same thing, except we now have just a picture of a circle, and we're going to try and use the circle to create a graph, and then the graph to kind of create our equation. So the first thing that it asks you is about the sinusoidal axis. So instead of initially looking at the picture, just think about what the sinusoidal axis means. Like, where is it in your normal graph, your normal sine-cosine graph? What does it do to the graph? So what is the sinusoidal axis, Virginia? Yeah, it's in the middle. So the sinusoidal axis is that line that goes in the middle of the graph. You have half of the graph above, you have the other half of the graph below. So Virginia, if you look at our water wheel, what do you think the sinusoidal axis would be?
6.
Yeah. So 6 is the sinusoidal axis, and Virginia, why do you say 6?
Because it's 6 from the water.
Yeah, so the center is 6 feet from the water. That's what your sinusoidal axis is, the center of your graph, the middle of your graph. So that's the middle of our circle, the center of the circle. That's why the sinusoidal axis would be 6. So the center of the circle is 6 feet above the water. So on my graph, I'm going to sketch in a sinusoidal axis so that I know where the center of my graph is supposed to be. So up 6, and I'm just making it a dashed line. So that's going to be the center of the graph. That means half the graph is going to be above the line, half the graph is going to be below the line. But the sinusoidal axis is just center of your graph. So the second question says, what is the amplitude? So remember, the amplitude is once you're at the center, how high above the center do you go, or how far below the center do you go? Brandon?
7 feet.
And why would that be 7 feet?
Because the arm of the bucket is 7 feet, and at the max value, it's 7 feet above the
Good,
sinusoidal axis.
sure. And what is that arm called?
The bucket arm, the radius.
Yeah, the radius. Yeah. So the radius of the circle is going to take you 7 feet above the center. It's also going to take you 7 feet below the center. That's where the bucket is. It's on the edge of it. So then question 3 wants you to think about the upper bound and the lower bound. So if that arm, the radius, is taking you 7 feet above the center, Brandon, the highest point would be
13 feet.
13 feet, because we already have the 6. Let me start with the 6. We're going 7 feet above that to get 13 feet. So we know we have to go up to 13 feet. That's up here. And Brandon, if it's going to take you 7 feet below the center, then you would be at
7 feet.
So if it spins around, how far below the
That's
center?
still 13 feet.
So the radius is this whole distance.
Okay.
This part is 6 feet above water. How much extra space would it be then underneath the water?
1 foot.
1 foot. So the lowest point would be the 6 current feet that it is above water minus the radius of 7. And that would be at -1. So our lowest value would be at -1. So the radius of the circle is above 7 feet above, or 7 feet from the center down. So really it's just an extra foot that it's underneath the water. So it's going underneath the water enough to scoop up the water. So now the y-axis is kind of labeled because we know the low, we know the middle, we know the high value. So the next question now gets you to think about that highest point and the phase shift. So what did the stopwatch read, or what did your phone read, a little clock on your phone, when point P was at the highest point? How long did it take to get to the highest point once you started the stopwatch? Chelsea?
2 seconds.
2 seconds. So on our little graph, if you go to where 2 seconds is, over 2 on the x-axis, you're now at 13 feet. And that's where your first point's going to be located. So at 2 seconds, it's at the top of the graph. Well, the top of the graph is 13 feet above the water. So that means our phase shift is 2, because the cosine starts at the maximum point. So when it's at the max of the circle, the water wheel is at the top, then that's also where our cosine starts. So the next question, now we want to figure out the period. So if we go back and read the first sentence over again. The water wheel rotates 6 revolutions per minute. We need to be able to figure out the period from that. Virginia?
Would it be 6 times 16, which is 300? Wait, no. Oh, it would be 10
Why 10?
because you divide a minute by 6.
Yeah, so it was 1 minute for 6 revolutions, but 1 minute is really 60 seconds for 6 revolutions, so the period is 10 seconds. So 6 revolutions in 60 seconds, 1 revolution in 10 seconds. So it takes 10 seconds for it to go all the way around. I guess I should have put my work over here. There was space. So So then question 6 says, where does the sinusoid, which is the graph, reach its next highest point? So if it starts at the highest point at 2 seconds, and it takes 10 seconds to get back to that highest point, Cade, if I'm at 2 and I go 10 seconds later, we're now at 12 seconds. So at 12 seconds, we're now at the highest point again. So at 2 seconds, it was at the highest point. 10 seconds later, you're now at 12 seconds, and it's back at the highest point. And that's just by adding your period to the initial amount. So we started at 2, we added 10, we now are at 12. So then questions 7 and 8, kind of using what you know about the graph. Number 7 says, where does it reach the low point? So looking at your graph, if you have your 2 high values, where is it going to be at the low value? Michael, where do you think it would be at the lowest point?
Maybe 6.
So
Or it'd be 7.
it would be 7. And you were doing some mental calculation. What were you doing there?
What was this, the point between 2 and 12?
Yeah, so you're looking for the point in between 2 and 12. If you add them together, you want to find the middle of 2 and 12. So 2 plus 12 is 14. Half of 14 is 7. So at 7, we're at the lowest point, which I'm going to actually move my 7 down. Right. So that's the point, and that point is at an x value of 7. It's halfway in between. So 5 seconds to get to 7, 5 more seconds to get to 12. And then question 8 says, when is it touch the sinusoidal axis? So the sinusoidal axis is that line that cuts the graph in half. So we want to know, when does that touch the sinusoidal axis? When does it touch the middle of the graph? Well, that has to be in the middle of 2 seconds in the middle of 7 seconds. Or the middle of 7 seconds in the middle of 12 seconds. So what is the middle of 2 and 7 seconds, Brandon?
4.5 seconds.
4.5, so 2, 3, so we're right here at 4.5. And Brandon, the middle of 7 and 12 seconds would be
9.5 seconds.
9.5. And now we have our 5 key points. So if you want to make yourself some notes down there, just so you know how you got them. So we had to be in the middle of 2 and 7. And then we had to be in the middle of 7 and 12. So everything you're pretty much cutting in half. So you're finding the middle of 2 points. You're finding the middle of 2 points. You're always just taking the 2 points, cutting them in half to get that middle value. So the last thing it says is to sketch the graph, which we have pretty much everything on the graph. We just need to connect our dots. Try and make it curved. Some of your graphs are not very curvy. These are not peaks. It's a nice wave, a curve. So we took our circular motion of the water wheel, and we've now created a sinusoid. We made ours look like a cosine graph. So the last part of it wants us to take all these pieces that we just found above so that we can try and write the equation. So we said the A was 7, the D was 6. Those are the first 2 things we found. D was the center, the 7, the A value was the radius. We found the period to be 10 seconds. It took 10 seconds to rotate once because 6 rotations were 60 seconds. So using what we know about the period is 2 pi over b. It's always a radian unless it says degrees. Always use radians. So Jenna, 2 pi over b equals 10 means b is equal to? Pi over 5. And then the phase shift is where the graph started at the highest point, which was 2 seconds. So writing the equation, we have 7. We drew a cosine graph, so we're writing a cosine equation. Period is pi over 5. And then, I think this is supposed to be a t. We'll put a t here. T and d. Technically. And then plus 6. So the distance that the bucket is away from the water It'll be 7 cosine pi over 5, and then t minus 2 plus 6, time minus 2 seconds. The last question says, use the equation to find the distance when time is 5.5 seconds. I just show your work. So the goal is just for you to kind of plug this in your calculator. You don't need to physically show a whole bunch of work, but I want to make sure you can plug it in your calculator. So we're plugging in 5.5. Which is really 3.5. So when you put this in your calculator, it is so important that you put an extra set of parentheses after the cosine and then before the plus 6. If you don't, it's not creating all of that as an angle together. So parentheses are really important. So you're going to need the probably parentheses around pi over 6 times the 3.5, but it needs to be able to take the cosine of all of that stuff. So that's why you need to put like a double set of parentheses there. But if you get a crazy answer, like the highest value is 13. If you get above 13, then you did something wrong in the calculator. The lowest value was -1. If you get below -1, you did something wrong with your calculator. But use the graph as a reference. So we're trying to find 5.5, which is just after 4.5. So like 5.5, my graph looks like it's between 1 and 2. So you should get a y value between 1 and 2 based off of the picture of the graph. Because we're looking at like this section right here at 5.5. Anybody get an answer? Sabrina, what do you think you got?
I got 1.885.
Yeah, that's perfect. Chelsea, did you get that too?
Yeah.
Awesome. And was this feet, inches, feet, not inches? What does it say at the top? My board doesn't want to go to the top. Feet. Questions? It's a lot to take in. It's a lot to think about. So the next 2 pages in your packet are circle problems. You got a Ferris wheel instead of a water wheel, but it's the same exact thing, same concept. So the Ferris wheel doesn't go into the ground because then you get people hurt. And then the clock hands problem. It'll give you a graph, and you're going to be plotting points on the graph, connecting them to try and write the equation of the curve. Questions? So we'll do a little bit more with this tomorrow, and then we'll just start reviewing for your test on Friday.